common things that we can do in most, if not all, VR games is we're able to grab specific objects in the environment. And this is honestly just a really neat thing to be able to do. Reach out, grab an object, and be able to manipulate it the way you would like to within the environment using your own two hands. But there's a lot of things that can go wrong with this. For example, just grabbing objects, we could have issues, for example, where players throw an object outside the bounds of the play area. We can have it so that way players somehow manage to smush it into a mesh or on the other side of one and no longer have access to that object. Or we could have, in some cases, players stick their hand through walls, let go, and drop an object and lose it forever. And that's just some of the things that are more commonly seen in a lot of VR games. There's also other issues where, for example, players may not have their floor space set up correctly, set up a little bit higher, and so they can't actually reach the floor. Or maybe the player just has an oddly shaped environment, or it's just really small and so they can't really move freely and be able to reach out for objects. So one solution to this very common issue is being able to grab objects from a distance. Now, I know that this isn't really realistic, but one of the huge benefits that this has is that this helps minimize a lot of those issues that we usually see, because players can simply stick out their hand, hit the grip, and automatically have that object appear in their hand. So they don't need to worry about having, for example, a small play space. So in this video, I'm going to show you exactly how we do that. And I'll start by showing you exactly what this will end up looking like. All right, so let me go and show you exactly how this distance grabbing works. So I don't think it popped up, but in case it did, you might have seen that we have these little red lines that are shooting between my controllers and the various blocks. And I can also hit those two back there as well. So what this is doing is this is checking to see what block I'm currently pointing at. Just for development purposes, being able to see exactly what we're trying to grab, I just have a little line shooting between my hand and whatever block we are trying to grab at the moment, or that we're pointing at to potentially grab here in a moment. So if we want to go ahead and grab a block, all we do is I'm going to do it with my right hand here. All we do is we just point at whichever one we want. So I can go and hit that one and it teleports straight to my hand and I'm grabbing it exactly as you would normally expect. Now I can also just kind of bring my hand up exactly as you normally would. You should be able to kind of see that I can grab it from like the edge. And that is part of the reason why we also teleport it to the hand, because the way that the grab component works, it also supports free grabbing, I believe is what it's called. And the free grabbing allows for you to grab anywhere so long as your motion controller is in contact with the object you're trying to grab. There is also snapping methods, which does basically the same thing as this. It'll just snap straight to where the grab component is. And then we can just go and grab it. And the same thing goes for my left hand. It's using the same distance grab component that I have here as well. So, and I can also, it does get a little bit harder once you start having more things just because of how close they are. But I can also go and I can reach behind and grab other objects that we have behind there as well. So let me go and jump into the video and I can show you exactly how this is all set up. Now first things first, we need to create a new component that we can attach onto our motion controller component. Now for this example, I'm going to be using a static mesh component, but the component type doesn't really matter. The reason I'm going to be using a static mesh component is we can give this mesh component an arrow, and this arrow will allow for us to check and see what direction we're looking for any sort of grab components. Now in addition to this, since I am using a static mesh component, I'm also going to make sure that this mesh component is hidden in game, which again isn't a necessity, but will just kind of make things look a little bit nicer since the player really doesn't need to see this arrow during the gameplay. Once we're done with this, I'm going to go ahead and remove the event begin play since we're really not going to need that for this tutorial. We're only going to need the event tick. And then I'm going to create three variables. First one is going to be called isDetecting with a little question mark at the end. And this is going to be a Boolean, and this is going to allow for us to either enable or at any point disable our detection for any sort of grab components. The second variable is going to be called ignore actors, and this is going to be an array of actors. We'll be manipulating this several times throughout the event tick. Then we'll also have a third component called targeted grab, and this is going to be a grab component, and this is just going to be whatever our currently targeted grab component is at the end of each tick. Once we have these variables in place, I'm going to go ahead and get the isDetecting Boolean variable and feed that into a branch. Then, assuming that this is true, I'm going to make sure that ignore actors is cleared, and I'm also going to make sure that targeted grab is clear. Since this is going to be run at the beginning of each tick, we want to make sure right off the bat that we're not going to have any sort of grab actors that we don't want, and that we don't have any ignore actors that we don't want. Once this is all done, we're going to run a sphere trace by channel. Now, in case you're not familiar with traces, this is pretty simple. We need a start vector, and this is going to be the world location of our component. And the end vector is going to be our current world location combined with our forward vector multiplied by some value. This some value, which is the float in this case, is going to be how far in that direction we're checking for any sort of grab components. Once we've given our sphere trace a start and end, we also need to give it a radius. In this example, I'm just going to give it 50. I find this a pretty good starting point. And then the ignore actors variable is going to go into the actors to ignore for our sphere trace by channel. Now this actors to ignore is actually pretty important. Even a multi-line trace will actually stop at the very first actor that it hits, meaning that if you don't actually hit something that has a grab component first, then it won't actually keep on going until it finds one. So what we're going to be doing by the end of this event tick is we're going to be running a loop to check everything that we hit within a direction. Then we'll go through each of these and check to see which ones have a grab component and which ones we actually may want to be targeting in that moment. Now after we run this sphere trace by channel, we're going to want to go ahead and break that out hit. Using this out hit, we want to get the blocking hit, and we want to run this into a branch to see if we've actually hit something. Now, assuming that we did hit anything, we want to go and grab the ignore actors variable, and we want to add on the hit actor into this array. Now once we've determined that we have or have not hit something, now we need to actually worry about whether or not this object that we've hit has a grab component and whether or not something we should be targeting. So I'm going to go ahead and get the hit actor. I'm going to check to see if it has a component by class. The class is going to be grab component, and I'll go and check to see if it is valid. Now as a quick note, starting at this is valid, and anything beyond this point we want to keep track, and we want to make sure that there's no just open execution nodes left open. At the end of this event tick, we're going to go back, and all these execution nodes that are just kind of left open with nowhere to run, we're going to be using these to loop back at the very end. So that way we can repeat this whole process, and this is all going to happen for every single actor that we hit in that direction. Now once we've confirmed that we have found a grab component, I want to first check the distance. Now this is optional, but I like to just check and make sure that's not within reaching distance of our hand. So I'm going to get the distance between our grab component and our current component that we're working on. I'm going to check to make sure that this distance is greater than or equal to 50 right off the bat. Once we've checked the distance between our grab component and our current component itself, next step is we want to go ahead and check to see if our targeted grab is valid. If it's not, we simply want to set our targeted grab to the current grab component that we just got. Now for targeted grab is valid, then we want to do a little comparison to check and see what it is that our hand is most likely pointed at. Now, the way I have found best to do this is I'm going to go ahead and get the world location of our current component, as well as our targeted grab and the grab component that we're currently working with on this loop. Using all three of these, I'm next going to want to go ahead and get the look at rotation between our current component and each of these grab components. Then using these, I'm going to get the forward vector of each of these as well as the forward vector of our current component. I'm going to compare all these together using a distance between the various vectors, and this is going to help me determine what it is we're most likely pointed at. Once we've reached the end of this, assuming that all of this comes out to true, we're going to then go ahead and set our targeted grab to be equal to this new grab component, because we're going to determine at this point that that's more likely what we're pointed at. Now, the last step is to go back and we want to grab every open execution node that's not currently running into anything whatsoever. And we want to go ahead and run that back to when we first started doing the sphere overlap. At this point, we've now likely added on a new actor that we want to ignore. So we want to go ahead and push that sphere overlap just a little bit further each and every time until we finally reach the end of that overall trace. And so that's what we're doing at this point. We're going to go back. All these execution nodes are going to run back into that. Now once we're done with this, we're not done quite yet. We need to add in two functions that are both going to be useful later on down the line as well. Now, the first function we want to worry about is related to that isDetecting variable that we're using at the very beginning of our event tick. Now, first off, I probably should have noted this right then, but I didn't actually set this variable to true right off the bat. We want to make sure that this is true, otherwise we will not start any of this detection and we're not actually going to start looking for any sort of grab components to grab onto. Now, the first function I'm going to create is just simply going to set this variable to either true or false. Are we detecting or are we not? And you don't have to do this. If you want to just access the variable directly, you certainly can. However, I personally like the look of just accessing a function as opposed to a variable. So for this example, I'm going to go ahead and put this into a function. Next, we're going to need a second function, and this one will be required for actually grabbing objects. Now, this function is going to be called grab, and it's going to have a single input of type motion controller, and I'm going to call this input motion controller. Then we're going to have two outputs. The first one's going to be called grab component, which is going to be a grab component, and the second output is going to be a boolean called isValid. Now, this boolean is again, not really necessary. If you want to just access the grab component directly and see if it's valid, you can do that as well. However, I prefer to just use a boolean for circumstances like this. So for me, I'm just going to use a boolean to check and see if the grab component that we're getting is valid in the first place. Once we have these inputs and outputs set up, we're going to want to first check and see if our targeted grab is valid. If it's not, we're going to end this function right there. We're simply going to run our return node and we're going to make sure that isValid is false. We're not going to put anything into the grab component. However, if this is valid, we want to make sure that we stop detecting, since we likely don't want to keep checking for more objects after this point. Next, I'm also going to go and grab the targeted grab. I'm going to convert that into a local variable. And this is really only necessary because we need it for the return value and because I like to clear variables when they're no longer in use. So I want to make sure that I go back and make sure that this grab component is no longer valid at all. So because of this, we need it temporarily stored as a local variable. So that's the whole reason for this part right here. Next, I'm going to go ahead and get the owner of our targeted grab. This should give us the actor that is currently holding on to this grab component. I'm going to set the actor location and rotation on this owner. And this location rotation is simply going to be the location and the rotation of our current component. Now, as a quick side note, you may need to set this teleport as true, as some objects, especially grab component objects, may start giving you warnings or errors if you don't set this to teleport. So just as a quick side note. Then finally, before we return, we also want to get either the targeted grab or our grab component that we have stored locally, and we want to try grab on it. And the input motion controller is going to be the motion controller input that we get from grab. I'm simply going to pull this in as a new variable instead of dragging through a whole new line just for this. So I'm just going to go and grab that exactly as you see here. Then don't forget to set the targeted grab as false. This should not cause any issues, but just as a precaution, I like to make sure that this is set to false right off the bat. And then we can go and run into our return node. For the return node, as I mentioned earlier, the grab component variable that we have stored locally is going to go in as the grab component output, and isValid will always be true, assuming that we followed this line of nodes. Now, as an option, if you would like to be able to see what it is that you're grabbing, there are many options to be able to see while you are testing. The option that I like best is I like to use draw debug line. This is pretty simple, and we already have all the parts that we need to do this. This is going to be run on the false, and what we'll do is we'll go ahead and check to see if we did in fact find a grab component, and assuming that we did, the start location is going to be our current world location of the component, and our end location is going to be the world location of the grab component that we found. And that's it for the component side. Now we need to actually jump into our VR pawn and actually use this component in the VR pawn itself. To use this component, we're going to go ahead and jump into each of our motion controllers, and each of these needs to get the distance grab component. Now, assuming that you're using a static mesh like I am, you should actually see the arrow in front of the motion controller itself. And this is going to point in whatever direction we're going to be casting in, and whatever direction we're going to be looking for those grab components. Once we have these both in place, we can go ahead and jump into the event graph. Now, one of the nice things about the way that this component is set up is we can still use our local grabbing that we would normally use. The only thing that we'll need to do is make a couple small modifications. Now I'll go ahead and start out with the grab left for our left hand. For this, I'm going to go and get the distance grab component left, and I'll run the grab function that we built into that component. After running this function, we want to get the isValid output, and we want to feed that into a branch. Now, if you are still planning on using the close-up grab like I had mentioned earlier on, the false will lead into the close-up grabbing. If you don't want to include any sort of close-up, normal grabbing, you can leave this part out and not have to worry about anything after that point. You can just leave the false completely alone. On true is where we're going to handle the distance grabbing. Now on true, if you're using the default VR pawn, you may have components that are labeled something similar to here, like held component left and held component right. And these just kind of hold on to the grab components that are currently being held in those hands. So I'll go ahead and get the held component left, and I need to set this to the grab component output that we get in the grab function. Next, on released, it's going to again be a very simple process. All we're going to do is we're going to get our distance grab component left, and we'll want to run the set detecting function, or if you're just using the Boolean variable directly, you want to go and set that variable. And on release, we just want to set that to true, so that way we start detecting again once we have finished the grab. Now I should know right now, just in case, If you are planning on removing everything after that's not necessary for the close-up grab, don't remove any of the other part of this release function. You still need to run everything that's left in there, but we're just adding this on as an addition before we release any objects that we're grabbing onto. Now, if you are still using the close-up grab like I am doing here, we also want to go to the end of the close-up grab, and after the point where we have officially found another grab component to grab at a close range, we want to make sure that we also turn off detection there, so that way we're not still checking for objects when we really shouldn't be, because we already have something in our hand. Once this is done, all we need to do is the same thing for the right hand. The only difference, of course, is going to be that we're going to trade out our held component left for held component right, and we're also going to go ahead and trade out our distance grab component left for distance grab component right. And that's it. Assuming you did everything correctly, you should now be able to reach out your hand, hit the grip button, and be able to grab objects even if they are outside of your reach. I hope you enjoyed this video. If you did, be sure to like and subscribe button down below. I also want to give a huge shout out to my Patreon supporters, who you should see down below. And with that, I'll see you in the next reality.